In this video, we will take a look at one of the characteristics of quadratic functions that many people just memorize. However, based on the math you have learned so far, this is something that you can master. So we'll take a look at it today. We start off with some generic quadratic function, f of x equals ax squared plus bx plus c. So we know it is a parabola. We know it has some vertex. That vertex in this case is at the origin, but it could be anywhere on the Cartesian plane. It could open up or it could open down. We know that it is a constantly curving graph. We're going to be either decreasing down into the vertex and increasing away, or it might have the parabola here, might increase, and then, not quite symmetrical. Might increase and then decrease. We do know it is symmetrical, though. There is some axis of symmetry that is right in the middle of the parabola. In this case, it would be the y-axis for the red graph here. And so how can we use this to help us find the axis of symmetry? Because it is constantly curving, is there a way to find out where this axis of symmetry is just based off looking at a generic quadratic function? The answer is yes, we can if we do a little bit of fun math involving slope. So so far we have looked at the idea that if I have some curve, I think we start off exponential curves. We did this a few times. I have some exponential curve here. I said, well, as this curves, its rate of change is changing constantly. Can I find the average rate of change, though, from some given x value to some other value? Maybe if this is x, this is, I don't know, x plus, just say h. I say, what's the average rate of change? Well, that's just the slope of the line that goes through those 2 points. Missed it there a little bit. That's the slope of that line. So if I can find the slope of this line right here between x and x plus h, that's the average rate of change. Let's go ahead and do that over here with our parabola. Let's say I have 2 points on my parabola, and we'll just go from, I don't know, let's go from do a line right through there. So we'll say from this point to this point. What's the average rate of change? Let's just call this input here x. So this will be x right here in the number line. And this input we'll say is x plus, we'll use h again here. So this distance from here to here in the number line is h units long. So because we're using variables with this, this will work with all numbers when we're done. So I want to find this rate of change for this function. Well, we know how to find rate of change. In very generic terms, we can say slope is change in y. So change in y, in this case f of x, over change in x. Again, Greek symbol delta for slope. And that's going to be equal to, that slope line's way too long, that's going to be equal to, so let's go ahead and start with this second point out here, x minus h. So let's just name these 2 points first, I guess. Let's call this point right here, this is x, comma, and the output would be f of x. That's one ordered pair. And this point here will be x plus h, whatever x value this is, and that's f of x plus h is the output. So here are my 2 points. I have x and the output for x on function f. Here I have some x value of x plus h, and this is my output right here. This distance right here is my output for x plus h. So what would my slope be? Well, I could do change in output, so f of x plus h minus f of x. So this output minus this output. A lot of variables here, but it's going to be okay. And then input minus input. So I did this output minus this output. Again, a lot of variables, but because we're using variables, we know this will work for all numbers then. So I have output minus output, change in output, over corresponding input minus corresponding input. Now we can just work on simplifying this. And maybe you don't see where this is going yet, and that's perfectly okay. But see how much of this you can simplify. Maybe hit pause here and see what you get. All right, so let's go ahead and simplify our denominator. So I know slope is equal to x plus h minus x. What is x plus h minus x? This one really long here for some work. X plus h minus x. This works out quite nicely. This is just h. Now for my numerator, I'm going to do f of x plus h. So I need to put x plus h in for x. So I'm going to scroll down here a little bit and do my work down here. So I'm going to do f of x plus h is equal to ax squared plus bx plus c. And x, the input in this case is x plus h. And now I can simplify this. I have a times a binomial squared. The square of a binomial produces a perfect square trinomial. If you don't have this pattern memorized yet and fully mastered, make sure you do work on that because we square binomials a lot in mathematics. Let's go ahead and show it off to the side here using an area model. So if I have a perfect square, length and width are equal, and that length and width are both written as a binomial, I get a nice little perfect square trinomial. So this is x long, and this is h long, and this is x long, and this is h long. I always get x squared. I get h times x. I get h by x. And I get h squared. So I'm going to get a times x squared plus 2 of these hx's plus h squared. Plus, I can distribute here. I get bx plus bh, and I get a c. Now I can distribute my a. So I get ax squared plus 2ahx plus ah squared plus bx plus bh plus c. So a lot's going on here, but this is what I get with my quadratic when I put x plus h in for x. This is the output. If this is still confusing to you, I'm going to hit pause, rewind, and watch this until this makes sense. All we did is we put x plus h in for x, then we multiplied, added. We've got this right here. So this is our first output fully simplified, not written in function notation, but actually putting x plus h in and getting an output. So we get a x squared plus 2ahx plus ah squared plus bx plus bh plus c. So this is our output. This is our output for this quantity right here. Now from this we need to subtract f of x. This will be very simple though because we already know what f of x is. We know f of x is ax squared plus bx plus c. I'm going to change colors here. It's a little bit easier to follow. But this is an entire quantity, so we're going to subtract from it ax squared plus bx plus c. So I need to remember to distribute my -1 to all of this. So I get ax squared minus ax squared. Well, these two terms will zero out, so make a zero pair right there. There's a bx minus a bx. Again, bx is in parentheses here, so bx minus bx is 0. And I have a c minus a c, so that makes a 0 pair. So now I'm left with slope is equal to 2ahx plus ah squared, so I've got this term, I've got this term, plus bh, I've got this term, all other terms have gone to 0, all over h. Now can we simplify this ratio any further? And we can because there's an h in every single term. So if I wanted to make this a bit clearer, I could distribute an h out of this sum and say, well, in terms of h, what do I have here? I have 2ax's, 2ax times h, plus a times h times h, plus b times h. So all I did here is I used the distributive property to factor out an h. If I use the distributive property to multiply, I'll get 2ahx, distribute the h in. H times ah is ah squared, and b times h is bh. So how does this help us? Well, h divided by h is 1. So h divided by h is 1. And now I know the slope of this line. We're going somewhere with this here. I know the slope of that line between any 2 points, some input and that same number plus some number. That number could be negative for all we know. H could be -3, x could be 1. But between any 2 given points, x and x plus h, the slope is always going to be 2ax plus ah plus b. I think, well, that was a lot of math, and that looked really cool and everything, but what does this do for me? It does something really neat, and this actually is tied into calculus. Because now what happens if we say, you know what, I want this h value here, that distance between these 2 points, I want that to get smaller and smaller and smaller and smaller and smaller and smaller until h is going to become 0, so they're the same point. So essentially I'm saying we do x and x plus 0. What's that rate of change? And that creates what's called a tangent line in mathematics, where you have a curve and you've got a straight line, and those two just meet at a point. So I'm just going to let h become 0, and it's the slope of that line tangent to the curve for any given value of x. So if I let h become 0, I get the slope is 2ax plus b. So now for any parabola, try to sketch a new one out here, it's not too bad. For any parabola, if I want to find some x value here on it, if I draw a line so it only touches the curve at just that moment, I can take that x value and I can find the slope of that line that just touches the line, or is just tangent to the curve. So how does this help me? Well, I want you to study the parabolic shape here. I want you to notice about how it either decreases and then increases. And think about where the axis of symmetry is, or it either increases and then decreases. And think about where the axis of symmetry is there. I want you to think about where that vertex is going to be. And then I want you to think about the line that's tangent to that point, no matter whether it's an increasing decreasing function or a decreasing increasing function. No matter how wide or how narrow it is, what do you know about the line tangent to the vertex? All right, it's going to be a horizontal line. It's always a horizontal line. And what do we know about the slope of every single horizontal line? We know the slope is 0 for horizontal lines. So now we can find the equation to the axis of symmetry. If we know the slope is 0, we already know the values for a and b. A and b are the coefficients of x squared and x. So I put a 0 in for m. I get 0 equals 2ax plus b. I want to know where the axis of symmetry is. What is the x value of the axis of, what is the equation of the vertical line? X equals what? Or I could say, what is the x coordinate of the vertex? So first I'll solve for this term by subtracting b from both sides. And I get negative b equals 2ax. Then I divide both sides by 2a, and I'm left with x equals opposite of b over 2a. If you master this, then you don't have to memorize this equation. You'll use this in later math courses. In Math 1, we typically just stick to finding two x-intercepts. We say here's an x-intercept, here's an x-intercept. Therefore, the axis of symmetry must be halfway between those 2 points, and then we can calculate the vertex given the axis of symmetry. Since the vertex is always the x value of the axis of symmetry, then you just put this back into your function. But anyway, follow these steps, see what questions you have. This is some pretty heavy math, but it's based off of things you've learned before. So if you study this enough and ask questions, this is something you can master at your level of mathematics, and this gives you a good doorway into calculus. So practice this. Let me know what questions you have. Make some errors, analyze them carefully, and have fun.